In our last video, we saw how we could set up just a very basic test. We created a simple computations object with the parameters 1 and 0.9, and then we used it right here, this sc1 object, called the compute method, and the difference between 1 and 0.9 should be 0.1, but it's not exact, and so we had to put in a little bit of tolerance. So let's take a quick look at why 1 minus 0.9 does not exactly give you 0.1. So remember this main function initializes a simple computations object with 1 and 0.4. Now let's switch that from 0.4 to 0.9, but before we do that, let's take a look at the results. With 0.4, 1 minus 0.4 is 0.6. We did that before, everything worked. So we switch that to 0.9, save it, run it, and take a look at this. It's not exactly 0.1, it's 0.1, 0, 0, 0, 0, 0, and then a 2, 4. And similarly, if you did a 1 divided by 0.9, we would get a 1.11111, and so on. And you would think that it would be repeating forever, but no, there's only finite precision in Java and in all programming languages if you use the primitive data types. And so in this case, it's not exactly 1.111 forever. There's a little bit of round off. Okay, so let's just test for this first in our test class. So let's get rid of this fail. We should just take it off completely. And let's say float temp is equal to, or let's say expected, that's probably better, is equal to 1.111 f, and float actual result is equal to sc1 dot compute, divide. And now we want to say assert equals expected first. Actually, there's not much of a difference, but this is the convention, is to put the expected value as the first parameter and the computed result second. And then let's try a tolerance 0. It should not work. Let's clean this up. Missing semicolon. Alright, let's save this. This should not work because 1 divided by 0.9 will give us 1. Well, we can see it right here, 1.1111112. 111111, and then there's a 2. So it's kind of hard to pin down that result. This should be close enough, of course it's not. Okay, so we know what the fix is. We have to put in a tolerance other than 0, but for now let's see what happens when you run this as a JUnit test. The test divide fails, and it fails right here, and so we know that we have to give it a little bit of slack. So 1111, that's good. Doesn't have to be exact. You can decide how much slack to give to particular computation. So now we want to run as JUnit, and this time around it passes. So another test passed. And similarly, we can find a way for the toString method to be tested and to make sure that it passes. Now we're down 4 runs, they all ran, there were 0 errors, and that program didn't crash. There was 1 failure, so the program ran, but this one still failed. Okay, so that's not a problem. So another thing that we want to look at is the use of the setup method that is before each test. So what we can do is, in addition to the static data member, we can have a regular instance data member. Let's say simple computations SC2, and SC2 is this instance data member, and we can set it up here. SC2 is equal to new simple computations, and we'll use some straightforward values like 1.0 f and 0. Let's say 6. That should work. Okay, so we set up these data. Okay, we set up this data member SC2. In teardown, we want to get rid of it. SC2 is equal to null. And then we can use them in all these test methods. So remember that the order in which the methods are executed is you do the setup before class first, then you do a setup, and then you do a test, and then you do a teardown, then you do a setup, another test, teardown, setup, another test. So we know that before this is executed, the setup will get run. So we can use the SC2 data member. So this would be like a test of the compute method using different data. So in this case, we can say float expected is equal to 1 minus 0.6, so 0.4, I believe. We double check what the numbers we put in were, 1 and 0.6, so the difference should be 0.4. And we'll say result is equal to sc2 dot compute, and we say assert. So remember that since this is an instance method, it can access both the static data members as well as the instance data members. That's why we can do both. Excuse me. So we can put expected here and result here, and we can probably use a much tighter tolerance for 1 minus 0.6. Let's try that. Save it, and then run as JUnit test, and it still passes. So if it had failed, wait a second, it did fail. Alright, maybe we do need to give it some slack. 0.0001 f. I guess we don't need to have the f there because it's expecting a double, and we're promoting these floats to doubles. Alright, let's try the tolerance. I was expecting that we would be able to get by without a tolerance, with a really small tolerance, but no, we did need a tiny amount of tolerance to make sure that we do get the right values. Okay, so we can also use this sc2 object in here. You can say expected value is 2.5. So what we're doing is 1 divided by 0.4, and you can say the result is sc2 dot divide, and let's see if it's exact. Cert equals expected result 0.0. Let's see if we can get away with it. Maybe we can. It'll always compile. The question is, when you run the test, is the actual result close enough? Oops. Run as JUnit test, and the test divide failed right there. So we do need a tolerance. So it's not exact. I'm going to keep the tolerance small as possible, but not too small. 0 is too small. Run as JUnit test, and still failed. Let's loosen up the tolerances. Save it. Maybe I'm computing something wrong. Oh, we're doing 1 divided by 0.6. Which should be, oh yeah, so notice it's not exactly 0.4, and this is 1.666666. Okay. So we were writing, I was doing my tests all wrong. So 0.4 was good, but I had the wrong value here. The expected value should be 1.666666. Okay, let's try this again. Run as JUnit test, and everything passes. Alright, so this was it was not about the tests themselves, but it was just showing you that you can set up both static and instance data members, which can be set up by the setup before class or by the setup method, and both of these can be used in our tests. So SC1, the static data member, can be used, the instance data member can be used in each one of the tests, and we can also see from here, it's not obvious, but if you debugged, you would be able to see that these SC2 objects would be reinitialized for every test method. So we can be confident that these setup methods, the setup by itself, setup method, it gets executed before every test method. In this case, it's not completely obvious, but you can do debug and see what order things were executed. So that's a basic, very basic introduction to JUnit, where we can write tests, use tolerances, set up all our data members before each test, and then finish and tear them down when we're done. Okay, very basic introduction to JUnit.